In today's session, we are going to discuss about K-maps, which is an important topic of digital electronics. Before we learn the simplification of Boolean expressions using the Boolean algebra. For the simplification of Boolean functions using Boolean algebra, we need better understanding of Boolean laws and theorems. And also during the process of simplification, we have to predict each succeeding steps. But in K-maps, it is a systematic approach for simplifying the Boolean functions. It is first proposed by Wesch and then modified by Karnoff. Hence it is known as Wesch diagram or Karnoff maps, simply K-maps. So K-map contains boxes called cells, and each of the cell represents one of the 2 power n possible combinations of n variables. So if there are n variables, 2 power n possible combinations are there, and here each box represents one of the 2 power n possible combinations. For a one variable K-map, 2 power 1 2 boxes or 2 cells will be there, and for a two variable K-map, 2 power 2 4 cells are there, and for a 3 variable K-map, 2 power 3 8 cells, and for a 4 variable K-map, 2 power 4 16 cells are there. So these are the outlines for a 1 variable, 2 variable, 3 variable and 4 variable K-maps. And each row and column of a K-map is labeled by a variable with its complements or with a combination of variables and their complements. For example, this is a one variable K-map with two cells. That one variable, if you're taking it as A, so this first cell represents A bar and second cell represents A. And if it is a two variable schema with four cells, those two variables, if you're taking it as A and B, so this A represents each row. That means first row will be represented by A bar, second row is represented by A, and here each column will be represented by the next variable B. For B we have B bar and B. That means this first cell represents A bar dot B bar, and the second cell represents A bar B, and this represented by A B bar, and for this cell it is represented by A and B. So this is how we are representing the cells of a K-map. Same way for a three variable K-map, if you are taking three variables as A, B, C, now A and complement of A is used to represent the rows, and next we have BC. So BC, product of BC and their complements is used to represent the columns of a K-map. So here A bar for this row, A for this row. Then for BC we have B bar C bar, B bar C, BC and BC bar, which represents one of the columns of this K-map. The first cell of this K-map is represented by A bar, B bar, C bar. Now second cell is represented by A bar, B bar, C. Third cell is represented by A bar, B, C. Fourth cell A bar, B, C bar. Same way here A, B bar, C bar, and for this cell it will be A, B bar, C, and for this cell A, B, C, and for this cell A, B, C bar. This is how we are representing the values to the K-map. Same way for a 4 variable K-map with 16 cells, if the 4 variables are A, B, C, D, A, B and their complements are used to represent one of the 4 rows of this K-map, and C, D and their complements are used to represent one of the 4 columns of this K-map. So here first row will be for A bar B bar, for the second row A bar B, for the third row A B, then for the fourth row it will be A B bar. And first column will be represented by C bar D bar, second column C bar D, third C D and fourth is C D bar. Now the first cell will be for A bar B bar C bar D bar. For the second cell it will be A bar B bar C bar D. Now here this value will be A bar B bar C D, and here A bar B bar C D bar. So this is how we are representing values to the K-map. But instead of labeling the rows and columns of a K-map by the variables, we use gray code for representing the cells of a K-map. Why we are using gray code is because gray code has unit distance property. That means if we take any two adjacent codes, they are differ only by 1 bit. And here also in the K-map, we want each cell to be differ only by 1 bit. So instead of binary, we will be using the gray code for representing the cells of a K-map. For example, for a 3 variable K-map, here we have BC combination. For BC combinations, we'll write it as 00011110 because gray code is this 00011110. And here we have only one variable A. For A, we have the combination 0 and 1. Same way for a 4 variable came up, here it is representing AB and here it will be represented by CD. For AB and CD, we will be writing it as 00011110 and here also 00011110. Now this cell value will be 0000, that means 0. And for this cell it will be 0001, that means 1. For this cell 0011, what is 0011 is equivalent to 3. And here this will be 0010, that means 2. So same way we are representing the values to the K-map, and here it is denoted by M0, M1, M3, M2 because we are talking about SOP function representation where the minterms will be represented to the cells of a K-map. And if you are going for the simplification of POS functions, then each cell represented by max terms. So M0, M1, M3, M2, these are the max terms. Now we will see how to represent values from a truth table to the K-map. In this truth table, two variables are there, A and B. So we should have a K-map with the 4 cells, 2 power 2 4 cells. Now the possible values of A will be used to represent the rows of the K-map and the possible values of B is used to represent the columns of the K-map. So here for A 0 1, for B also 0 1. Now what is the value of this cell? 0 0. Now for 0 0, what is the output value? Y 0. So that 0 will be represented to this cell. Then for 0 1, the value is 1. So for 0 1, 0 1 means represented by this cell. So in this cell, we have to write Y value 1. Next cell is 1 0. For 1 0, the value is 1. Output function value is 1. So that will be represented to this cell. The next cell value is what? 1 1. For 1 1, we have the value as 0. So 0 is represented to this cell. And this is the representation of a 3 variable truth table to the K-map. So 3 variables are A, B, C. So we have to go for K-map with the 2 power 3 8 cells. So this is the outline of the K-map. And here the 3 variables are A, B, C. So A, possible combinations of A is used to represent the rows of the K-map, and possible combinations of BC, that means 00011110, is used to represent the columns of the K-map. Now, this is the first cell. What is the value of this cell? 0, 0, 0. Now, for 0, 0, 0, the Y value is 0. So, that 0 is represented to this cell. Now, for next cell value is 0, 0, 1. For 0, 0, 1, the value is 0. So, that 0 is represented to this cell. Next, we have for this cell, what is the value? 0, 1, 1. For 0, 1, 1, the value is 0. So, that 0 is represented to this cell. Now what is the value of this cell? 0, 1, 0. For 0, 1, 0, the Y value is 1. So this 1 is represented to this cell. Next for this cell, 1, 0, 0. For 1, 0, 0, it is 1. So 1 is represented here. Next for this cell, 1, 0, 1. For 1, 0, 1, the Y value is 1. So 1 is represented here. Next for 1, 1, 0. 1, 1, 0. This cell. So the 0 is represented to this cell. Then last for 1, 1, 1. 1, 1, 1, which cell is 1, 1, 1? Here it is 1 and 1, 1. So this cell, by value is 1. So that is represented here. So this is how we have to represent a 4 variable truth table to the K-map. So 4 variables are A, B, C, D. So A, B, possible combinations of A, B is used to represent the rows of the K-map, and the possible combinations of C, D is used to represent the columns of the K-map. Now for 0, 0, 0, 0, the Y value is 0. So that 0 is represented to the first cell. Why first cell? The first cell value is 0, 0, 0, 0. Now the second cell value is 0, 0, 0, 1. For 0, 0, 0, 1, the output value is 1. So 1 is represented to this cell. Then for this cell value is 0, 0, 1, 1. For 0, 0, 1, 1, it is 1. So 1 is represented to this cell. So by seeing the input combination, values of the input combination, we have to represent to the respective cells to the K-map. Now we will see how to represent a standard SOP function to the K-map. So here is an example. The Boolean expression given is y is equal to ABC bar plus ABC plus A bar B bar C. Now here, how many variables are there? 3 variables are there. So we have to go for K-map with 2 power 3, 8 cells. Now the variables are A, B, C. So the possible combination of A. 0 and 1 is used to represent the rows of the K-map. Now the possible combinations of BC 00011110 is used to represent the columns of the K-map. Now we need to represent this equation to the K-map. So this is an SOP function. Each term is known as min term. So here the first min term is A, B, C bar. A, B, C bar means it is 110, right? 110. Now which cell is represented by 110? This is 1. Then we have 10. That means this cell. So 110, it is a min term that should be represented by 1 to the K-map. Now the next min term is ABC. So ABC means the value is 111, right? 111. Now that cell also should be represented by 1. So 111, that means this cell. So here also we need to put a 1, represents the min term of the SOP function. Now the next min term is A bar B bar C. A bar B bar C means it is 001. So which cell represents 001? 001, this cell. So here also we need to put a 1 that represents the min term. So here three min terms are there in the function A B C bar, A B C and A bar B bar C. So this cell represents A B C bar and this cell represents A B C and this cell represents A bar B bar C, and each minterm should be represented by 1 in the K-map. So remember, in SOP function, each minterm will be represented by 1 to the K-map and the remaining cell should be filled with zeros. So now we will see a 4 variable function. This is the function y is equal to a bar b c bar d bar plus a b bar c d bar plus a bar b c d bar plus a b bar c d. Now the first minterm is a bar b c bar d bar. That means a bar 0, b 1, c bar d bar means 0 0. So the value is 0 1 0 0. Now we need to see which cell represents 0 1 0 0. So this is a 4 variable came up with the 16 cells. So the possible combination of AB represents one of the 4 rows and the possible combinations of CD 0 0 0 1 1 1 1 0 represents one of the 4 columns of the K-map. Now what is the first minterm? 0 1 0 0. So which cell represents 0 1 0 0? See here 0 1 and 0 0. 0 1 0 0 means this cell. So here this is the first minterm should be represented by 1. Now the next minterm is A B bar C D bar. That means A B bar 1 0, C D bar 1 0. That means 1 0 1 0. So 1 0 1 0 means which cell is 1 0 1 0? Here this is 1 0 and again 1 0 1 0 1 0. That means this cell. So this cell also should be represented by 1. That is the second minterm. Now the next minterm is what? A bar B C D bar. That means 0 1 1 0. 0 1 1 0. Now which cell is represented by 0 1 1 0? This is 0 1 and 1 0. So this cell. So here also we need to put a 1 because that is also a minterm 0 1 1 0. Now the next minterm is 1011. So which cell is 1011? 1011. This cell. So there also we need to put a 1, that is also a minterm. So here in this function 4 minterms are there. Those 4 minterms are represented by 1 in the K-map and the remaining cell should be filled with a 0. We need to see the A, B, C, D values and corresponding cell should be filled with 1s for the minterm and the remaining cell should be filled with zeros. Now we will see how to represent a standard POS function to the K-map. Exactly the reverse we need to do here. We'll see an example here. Y is equal to A plus B bar plus C dot A plus B bar plus C bar dot A bar plus B bar plus C dot A plus B plus C bar. Now here, how many max terms are there? 1, 2, 3, 4. These 4 max terms should be represented to the K-map by zeros and the remaining cell should be filled with ones. Now we will see how many variables are there. 3 variables are there. So we need to go for K-map with 2 power 3, 8 cells. Now here A, possible combinations of A will be used to represent the rows and the possible combinations of BC is used to represent the columns of the K-map. Now we will see the max terms one by one. The first max term is A plus B bar plus C. A plus B bar plus C. And here remember, while writing the max term, a normal variable is used to represent 0 and a complemented variable is used to represent 1. So for A plus B bar plus C, the max term is 0, 1, 0. So 0, 1, 0. Which cell represents 0, 1, 0, 0, 1, 0? This cell. So here we need to put a 0 because max terms are represented by zeros to the k map. Now the next max term is a plus b bar plus c bar. A plus b bar plus c bar. For a we need to write 0. For b bar and c bar we need to write it as 1, 1. So the max term is 0, 1, 1. Which cell represents 0, 1, 1? This is 0, 1, 1. This cell. So this cell should be represented by 0. This max term should be represented by zeros to this cell. Now the next max term is a bar plus b bar plus c. A bar plus b bar plus c means it is 1, 1, 0. 1, 1, 0. Which cell represents 1, 1, 0? Here it is 1, then 1, 0. This cell. There also we need to put a 0. Next max term is a plus b plus c bar. A plus b plus c bar means it is 0, 0, 1. So 0, 0, 1. Which cell is 0, 0, 1? 0, 0, 1. This cell. There also we need to put 0. So we got 4 max terms. Remember, max terms are represented by zeros to the k map and min terms are represented by ones to the k map. So and remaining cell should be filled with ones. Now we will see an example for a 4 variable POS function. So 4 variables are there. So we need to go for came up with a 2 power 4 16 cells and the variables are A, B, C, D. So here AB, possible combinations of AB we are writing here and possible combinations of CD we are writing here. Now we will see the max terms one by one. So the first max term is A plus B plus C plus D bar. A plus B plus C plus D bar is represented by 0, 0, 0, 1. So that cell, which cell is 0, 0, 0, 1? 0, 0, 0, 1. This cell. We need to put a 0. Now the next max term is A plus B bar plus C bar plus D. What is the cell number here? 0, 1, 1, 0. Which cell is 0, 1, 1, 0, 0, 1, 1, 0. This cell. So here also we need to put a 0. Next max term is A plus B plus C bar plus D bar. Cell number will be 0, 0, 1, 1. Which cell is 0, 0, 1, 1? Here 0, 0, 1, 1. So this cell we need to put a 0. Next max term is A bar plus B bar plus C plus D bar. So this will be 1, 1, 0, 1. Where is 1, 1, 0, 1? This is 1, 1 and 0, 1. This is 0, 1. So this cell we need to put a 0. Next we have A bar plus B bar plus C bar plus D. That means 1, 1, 1, 0. Which cell is 1, 1, 1, 0, 1, 1 and 1, 0. This cell we need to put a 0. So we have 1, 2, 3, 4, 5, 5 max terms. All these 5 max terms are represented by zeros to the k map and the remaining cells are filled with ones. So this is how we need to represent a POS function to the k map. Now in the next session we will see how to group these ones and zeros after representing the values to the k map for the simplification of Boolean functions.